Hello, pardon me while I get some things set up. I need to set up my sources. There we go. I don't know why I need to do that every time. You know what? Twitch probably isn't going to show up there, even if there are. Oh, I didn't think about that. Let's pull up Twitch. Okay. Let's get going with this. This might be a relatively short stream. We'll see. Welcome to anyone who may be viewing. Oops. I'm going to take this code and paste it over on my other screen so that I can refer to it as I develop this, but I am going to, oh, let me move my mic a bit. Turning up the volume. So I have some raw data. If I was doing this a clever way, I could write like a Python script to pull out the numbers, but I'm going to instead just say whether, maybe I'll go back and do the Python script approach, but for now I feel like just doing it this way. Wait, why does it say code words? Oh, right, duh, because I haven't updated it. We're actually doing data as music development, and let's check that that's the same thing on YouTube. Okay, data as music development, but I don't want the gaming category. Is it always going to default to gaming? I wonder. Code is development. Developing data to make music. Add some music to this, tags. Oh, musician? I don't want to do that. Got my T over here. Hey, we've got a follow from Pratty. Thank you very much. Oh, there goes my laundry machine. I forgot that that would be noisy on stream. I apologize. Okay. What's the syntax here? It's ring, and then I start with the numbers. And I'm going to I'll do the high and the low. 80, 60, make sure we can see that well enough. Let's zoom in a bit. I'm zooming in as far as it goes. Okay. 66, 54, 74, 51. Whoa. I'm just going to let this be. Also, I'm going to stop trying to type them because it's just 58, 50, 58, 52, 65, 55, 70, 7, 60, 75, 66, 77, 60, comma, close the paren, 64. Okay. Now what can I do with this? Let's notice that, take another sip of tea. Can I do, I'm not super great with Ruby, so some of this is making guesses, but can I put S the minimum of weather data, and is that going to work? Undefined method, how about minimum? Okay, it's not going to happen. I'm just going to have to do this manually. Can I do vector operations? Weather data. Or maybe I'll do this with Python. That'll just make things a whole lot easier, won't it? Bring up iterm, IPython. Make this nice and bigger. Data equal a list of these things in it. Min of weather data is 51. Max of weather data is 81. What am I going to do with that information? I'm going to do this on a, I'm going to do port numpy as np. Kind of slow. A equals np dot, is it nd array of weather data? Array is too big. The array size times array item is larger than the maximum possible size. Oops, I forgot how to use NumPy. There we go. That was easier than I thought. So a minus 51 gives us the numbers from 0 to 30, and a minus 51 divided by 81 times, we'll do 1024. Is that the right number of bits? Two to the 8. The power of 8 is, okay, we want this, I want this to be 256. So now these should be numbers between, where's the big ones? I subtracted a, so that's I subtracted 51, so this data is not going to make sense. I need to find the max of a minus 51. 30, okay. So we take that whole thing and take it by 30, divide by 30 times 56. And now we should see numbers. Yeah, there's a 200. There should be a 256. Oh, there it is right at the beginning. So offset equals all of that. What if I do int of offset? Map of a of offset, comma, map to int. Type object is not iterable. Oh, maybe I have to say map offset, comma, int. Okay, I don't know how to use the map function. Darn it. Oh, I know what to do. Int offset equals int of x for x in A. Okay. Nope, that's not right. There we go, 256 down to 25, and there's a 0 in there somewhere. So now weather data is a ring with those things in it. Let me make my reference scope a little bigger. And now I'll talk about what I'm going to do next. I'm going to take I equals 0. I'm doing this manually because I don't know the more like nice ways to do it. So that's just the way it's happening right now. Next, I'm going to make a live loop called binary do n equals weather data at position I, and I have this in 8 bits, so 8.times do if take the modulus of n with 2, and if that's equal to 1, then we do something, sample elec blip at amp 1 and why is this at a different offset? Maybe it'll, well, I'm not going to worry about that for now. So after that, n equal n bit shift by 1. Huh. Do I need the 8.times do? Oh, I don't need the do here, I need a then. That's better. I plus equal 1 end. So let's just listen to that now. Something is wrong. Oh, elect blip. That's why it's not working. It's not doing what I would expect it to do. I expect beep, 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 beep at the very beginning. Oh, 256 is 1 followed by 7 zeros. If I wanted it to be, if I wanted it to start off there, I'd have to make that 255. In fact, we don't have room for 256 in 8 bits. 8 bits can only go from 0 to 255. Let's subtract 1 off of here. And then it'll work out nicer. Okay. Okay, we got it now. So what's happening here? There's this ring. Is like a list, but you can it's set up to automatically go to the end and then whoop, loop back to the beginning. That's what makes it a ring instead of just a normal list. Weather data is ring, and notice that these numbers, some of them are bigger, 256, one of them is real small, it's 0, and then they're in between. And now listen to how sometimes there's a lot of beeps and sometimes there's fewer beeps. I'll explain in more detail in a bit, but suffice to say that sorry guys, I let myself get distracted. What was I gonna say? Oh, more beeps means a higher number, means a hotter temperature, and fewer beeps means a lower number, means a lower temperature. So listen to how it's like sometimes lots of beeps and sometimes fewer beeps. Also, we can watch the numbers here. Where are we? Oh, it's because I subtracted 1 from each of them. Okay, let's improve this a little bit by adding a beat to the background so that we can hear what's going on. So I'll add a, let's see, this is happening 8 times with a sleep of 0.25. I can't call it binary, they have to be distinct names. Do 2.times do sample BD 808 and let's see how well we can hear that. I'll add the snare in too. Live loop snare do sleep 0.5 sample snare dub amp colon 0.5 sleep 0.5 sample, the same thing. Sample the same thing, sleep 0.25, so the snare is going to hit twice on the later beats. And another sleep 0.25. And that all should now oops. I forgot the sleep 1 on my bass drum. It doesn't like that. You know what? Let's do this a little differently. I don't like this. Sample, just to make it easier to hear. Sample elect beep amp. Yeah, just as it is. Run that. I don't like that either. I'm trying to make this maybe more musical than it's ever going to be. Let's take a quick break. Be right back. Okay, let's get back into this. How can I make this so I like it better? I'm gonna set this to 0.5 and I'm going to do this 4 times because now we're doing this 8 times and sleeping for 0.5. That means we're sleeping for a total of 4. And we'll sleep for 1 and sleep for 1. Let's try this. Use BPM 105. Something's weird. What's happening? I'm going to close my eyes and listen and see if I can figure out what I've done wrong. This should be 4 times. Actually, if it has a length of okay. There it is. Amp, let's increase the amplitude on the bass drum because it's a little hard to hear, and take the snare down to 0.25. Try that. Okay, that's okay. I think it'd be better if it were, if there was a melody and it could go like part of the way through the melody. So let's do J equals 0, and each time through this, J plus equals 1, and melody equals, what's the, hold on, let's put freq to MIDI 440. I just want to know what the MIDI number is for A440. Okay, hold on. Well, whatever. We'll just, I think 60 is like a, how do you use a synth in this? I've gone and forgotten that. Where's the help? Synth options. Amplitude, amp it up. Panning, I don't care about switching synths. There we go. Let's try use synth profit. Oops. Use synth profit. Then play melody at, where's my melody? We're going to call this, start at 60. I need up to 8 of these. Do 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 do. Okay, we'll do it that way. 60, 62, 64, 60, 64, 62, and up a fifth is up 7, so 67. Did I do that right? Am I remembering my music theory? Play melody at, oh, and this, I think I need to use this kind of a paren here. Melody J. Let's try that. Stop. Let's try that. Something clearly is not doing what I want it to be doing. Am I missing something? Oh, here we go. Melody equal unexpected comma expecting. Okay, maybe it is. Maybe it is brackets. It's a little better, but it's a little simplified. Melody random equal melody dot shuffle. Probably going to, and then use melody random. Gonna comment out that silly electric beep, and here we go. This is actually working. Okay. Let it go for a while. All right. I almost got it landing on what sounded like a definitive ending point. Almost. So let's talk through all the pieces of this again. We have the weather data. Let me think for a second. Yeah, okay. Let's talk through the pieces of this. We have the weather data, which is a ring, which just means it's like a list or an array, but you can loop over it again and again. That starts at 256, goes up and down. This is taken from weather data. Yeah, it's weather data, my weather forecast for the next week or so. You notice it's high and then the low and then the high and then the low. But it's adjusted on a 0 to 256 scale, which is actually a problem. Because let's do it this way. We'll do we'll do it on 0 to 255. So then we don't need that -1. Okay. We're using a particular synth called Prophet. We're using 105 beats per minute. This melody is a sequence of numbers, but if I sing this melody, here comes my singing voice, cover your ears. If I sing this melody, it goes la 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 la. Wait, what? I have to think it through. La 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 la. It's like that. Just a nice little melody. Now we have an I counter. I'll come back to what that does. We have a live loop called binary. I won't explain what live loops are, but I'll link in the description here. If someday this turns into a video, I will link in the description. Spoiler alert, this is probably going to turn into a video. Live loop called binary, do this. N is from weather data at position I. Again, that starts at 0, but then every time through this level of the loop, it increments to +1. And you might be wondering, well, what if it goes beyond the end of the ring? That's the nice thing about rings. They can just get repeated. Pardon me. It can just go back from 25 to 255. Puts, it stands for put string. This is why if I scroll back up, you should be able to, 75. There's a 76 in here. I was subtracting 1. I'm not doing that anymore. I think I might try this explanation again. This is almost like a practice run, I'm beginning to feel. Melody random equals take the melody and shuffle it. It turns out there is a shuffle command in Sonic Pi. I was going to say in Ruby, but I'm not sure if it's in standard Ruby. I guess what we have in Sonic Pi might be like an extension of Ruby. J equals 0. Then 8 times do if n modulo 2 equals 1. In other words, if it's an odd number, so we're looking at the least significant digit in binary, if we're thinking of it as a binary number, then we play from the randomized melody at position J. And what is J? It started at 0, and it increments by 1 every time we go through this part of the loop. So it might be like if j is 1, we might get this guy because it was pushed back to the beginning, and then this one, and then that one, and then that one. And here, this is the bit shift operator. It takes the binary representation, like let's say, well, let's look at 255. 255 is it's right 2, 4, 8, 16, 32, 64, 128. Wait, this is 1. This is, anyway, I'm pretty sure this is right. What it does is it shifts everything over to the right one. So if we had like a 0 here, that might make it easier to see. It shifts that and throws it away and adds a 0 over there. So the next time we go through this loop, we'll be asking if it's kind of like if it's an odd number in the 2 to the 2 power position. Whether, in other words, whether or not there's a binary digit at this point in the binary representation. Sleep 0.5, that just makes it wait until the next one comes along. And that's that part of the code. And then the rest of it is just, I can comment out, well, I'll leave the electric bleep there. This has, it's just a bass drum that's kicking every one beat, and the snare is kicking every other beat. So it's sleep 1, snare, and that. So let's listen to it again. Just gonna let this chill for a while. Okay. I'm feeling good about that. What can we do to improve this, though? Let me just check a few things. Yeah, that's going okay. What else? I've done what I set out to do on this stream, so I might make it a short one. And just end up here. Would that be okay? I think that would be okay. I got some water. I wonder if there's a way I can, instead of just shuffling this, oh, I think the shuffle's working pretty well. Yeah, I'm gonna call the stream. I'm gonna call it here. I think I'm gonna try to package some of this stuff as a video.